So I'm going to take us live on YouTube, start that, so folks are able to see that now, and then we'll get started here in just a moment.
All right.
And Dylan's here, our lab manager. So
very nice.
Yeah.
I've got the whole team. Perfect.
And what we'll do is we'll just try to go mute for everybody but the speaker at that time. And it could be you, it could be me. But I think that'll help with the sound quality and so forth.
Oh, yes, definitely. Definitely. And I see our participants joining in. We have Akil joining in as well. Oh boy, I can't pronounce this one. I'm sorry. We have another one joining us as well. Thank you all for joining us.
Yeah, that's the safest way to go, right?
Yes, I don't want to mispronounce it. So you all will definitely have to help me. I'll work on my accent. I'll work on my Middle Eastern accent and try and get that perfected in time.
Well, you'll have to do that because it's hopeless for me as an American.
Oh my God. Oh boy. I will try. I will try my best. So I'm seeing a couple of people joining in, and we'll just give them a little bit of time because I know because it's later in the night for them, they'll have a couple of things that they need to probably wrap up as well before they join us. So I'm totally okay with that. Very appreciative that they have decided to, spend some time with us.
And for the list that you sent everything out to, have you kicked out the YouTube link to that list as well? Great. Okay. Because it gives folks another option, right? Because it can be frustrating if you've got a technical issue there or something.
Oh, yeah.
Hopefully another option helps. And then finally recording it, right, will be the key there, so we can go back and give people that link later if something doesn't go right. So.
For sure. Yeah, and then I know some people couldn't make it at this time as well.
Yeah, so right. That makes sense.
They just signed up and they will definitely watch the recording. I want to say tomorrow, but they will definitely watch the recording soon.
Well, everybody's so busy. Folks who have responsibility with asset management, they're busy folks. So it's good to give some options to take a little downtime at some point and be able to look for something like this. So I'm going to hit the recording here as well, just as double down there, and then I think whenever you're ready, we could.
Yeah, because I'm seeing a lot more people joining in, so I want to give them like 1 more minute just to join in, just because I know of what we're working with. So many different time zones. So 1 more minute just to join in and get settled in. And we will probably start in a bit because we're broadcasting on YouTube as well. So I know we have a lot of them coming in. So what I think would be a good thing for us to do while we wait for some people to join in is just kind of talk a little bit about how this got started. So I know Hamzaton is the pillar of this initially. Thank you so much for having the idea. So I'm going to give a brief background from what I know, and I'm going to let Rich and Hamzaton take it over in terms of how they came into the discussions and started to bring all of this together. But in a quick nutshell, Hamzaton, he did some grease analysis, and he's like, we need to have more people involved in this. We need to help bring the awareness levels up because this is critical. It's so important that we monitor our assets, everything, especially grease, because that could go unnoticed for so many people. They sometimes focus on the oil analysis and miss the grease analysis. and all of your assets are important. So Greece is important as well. And he was having conversations with Rich, and then they started to get me involved. And I'm like, yes, let's spread it to the whole of the Middle East. So basically, that's what we're trying to do with these series of webinars and getting more people involved. The main thing is really spreading the information, sharing the information, getting more people involved so that they know about case analysis, they know the benefits of it, and they can take that back to their plant or their facility and really, make use of it because nobody likes downtime unless it's for the holidays, unless you're personally taking downtime for the holidays. But with your equipment, we don't really like that downtime. So I'm going to pass it over to Rich so he gives a little bit of a brief introduction. And Rich needs no introduction. We know who Rich is. He is the Grease Steve. So he is definitely the one that we are going to for these Grease analysis stuff.
Thank you very much, Sonia. Yeah, for those who haven't, and I'm sure there's folks who are just here to learn and find out. My name is Rich Wurzbach. I work in Pennsylvania in the United States, and I've been working in the areas of oil and grease analysis for over 30 years. I started in the nuclear power industry in the U.S. I was a student of Ray Daly when I first got started, and he taught me how to do analytical ferrography for oils and for greases, and that kind of got things started. So over the years, I've had opportunities to work with critical assets that are grease lubricated, and I found that there was not a lot of options to address two important aspects of successful understanding of greases, and that is the sampling aspect as well as the analysis of grease samples, which are much different in nature than oil samples. So what we're looking to do today, and again, I'd also like to echo the comments from Sonia about Hamsatun bringing us together. His leadership and his insight here, I think, has been really the genesis of this and created this opportunity. And so we're following his lead to say, let's take what's out there and what is known, what has been done, what has been successful in other parts of the world, and let's present it to the folks in the kingdom and the surrounding countries to find where opportunities may be to take it further. And so that's what I'm looking to do today. So this is the first of a series of events that Sonia is helping us coordinate. This is the first one, and we're calling this Blitz as a way let's just kick it off with some speed, some excitement, some high level stuff, and possibly start the relationships here that will generate questions about things, what can be done, what's out there, and maybe kind of steer us through the rest of the process. So I'll take this moment to load the presentation that we have for today, and that is the KSA Grease Blitz. And I'll get that started here. And what I will do, and I think I'm going to go into the kind of the full screen representation. So let me see the best way to do that. I'm going to hit the full screen here and then get rid of that. And we'll start with this landing slide. And Sonia, does that appear good for everybody? Is it large and visible and we can roll through like this?
To go.
Okay, super. All right. So, one of the first things we want to think about is, we want to be successful and think about how do we establish a successful grease program? What are the elements? How do we get there? We'll talk a little bit too about how you decide whether you should have a grease analysis program or why you have a grease analysis program. But being successful should be top of mind, and that should be, what we're all driving for. And so if we want to be successful at grease analysis, we want to identify components that are high value or critical for operations and start there. Because when you're looking to do something new, there's always that question, well, why are we doing this? Why are we expending the resources, the funds, the time to do this. And the best way to show that and to demonstrate that is with high value or critical components. It could be components that historically have been a trouble spot, a pain point for facilities. And if we can demonstrate value, if we can change that result up with grease analysis, then the value is going to be obvious, and we're going to get continued support for that effort. But it all starts with sampling. If we don't have a representative sample, this applies for oils or greases, right? If we don't have a representative sample, it doesn't matter what analysis we're going to do. We're not going to get the right result. And those of us who have done oil analysis over the years have recognized that. Sometimes we learn that the hard way. We have samples that are going out. Maybe we're only focused on the data, and a failure happens and we didn't anticipate it, and we later find out it's because the samples weren't taken from the right place. They were taken from a dead leg, or they were taken after the machine had been shut off for a long period of time. Well, that kind of knowledge that's out there about oil analysis has to be applied to grease analysis as well, and it's even a little bit trickier, and that's because grease doesn't easily leave the machine, okay? And it's by design, right? Why do we use grease? Because it stays in place. It's designed and formulated to stick to the machine, stay where we put it, and not leak out and run out, which means it's harder to get it back out when it's time to sample it. But there is a standard, and the standard is an ASTM standard D7718, and it really outlines for us what are the considerations, what are the methods, what are the tools to be used to get a representative sample. Those that are taking grease samples should be trained, know the expectations, and know how to take a representative sample. Sonia, I had a very fortunate opportunity to meet with one of the leading scientists in the field of sampling, the theory of sampling. There's actually a theory of sampling, and he's Dr. Kim Esbensen from Denmark. And he's really been the standard bearer for this discipline of sampling. And I got the chance to work with him on some wind turbine projects where we focused at the very fundamental level about taking representative samples. So everything you see here that we're going to talk about today around sampling is based in science. It's based in the practice of sampling and the methods that are well understood in that discipline. And we find them in this ASTM standard D7718. Other elements to be successful once we get a method in place to take a representative sample is to have a good and open dialogue with your lab to understand what tests need to be done, how they're being performed, how we can put our confidence in them, the quality process that goes into analysis. We can also focus on root cause analysis, and sometimes that's where we start with grease analysis. We've got problems, we've had failures. We want to understand them and change some things so those failures don't happen over and over again. And root cause analysis can help improve our lubrication program by pinpointing the reasons behind failures or damaged equipment. And so that's a big part of this. And then another is just ending up with a set schedule for sampling to build some kind of trend history. If I see a difference in approach to grease analysis, it's often this. There's a problem, people take some grease samples, they analyze them, they get some knowledge about that problem, and then we don't hear from them again. And they lose the opportunity to build a history, to build a trend, to know where things are going on their critical grease lubricated components. And I think that's a missed opportunity. So having a set schedule for sampling to build that trend history can be very helpful. So the benefits of routine grease analysis in that way are to evaluate the reliability of the machine and the grease to perform its function. It looks like someone might be clicking on the screen right now, clicking around, and I think they're taking control of my slides here. So I'll ask that you refrain from doing that while I'm going through here, but this puts me back on this slide. So it's, again, evaluating the reliability of the machine and the grease itself to perform its function. So another area, when people first look at grease analysis, they're like, I'm looking for wear particles. I'm looking for damage. Nothing wrong with that. And that can be a great place to start. But if you aren't also looking at the function of the grease, the condition of the grease, you're going to miss the opportunity to identify a problem before it becomes much, much worse. If we only look at the wear particles, we miss the opportunity to look at changes in grease consistency, its ability to stay in place and perform its function, changes in oxidation levels of the grease, and other things that will impact the grease's effectiveness and its ability to perform its function. We look for signs of mixing of greases. Over the years, I've seen this to be a huge problem in industry, is that there's just at the grease gun end of things, a lack of understanding of how critical it is to get the right grease delivered at the right time, at the right quantities. And so when you don't understand that, and when that has not been well communicated, we end up with grease mixing. And there's just situations that naturally lead into mixing of different products. We buy the machine from a supplier. It already has some grease in it. It shows up at our facility. We put some grease that we have in it. Maybe they're not the same product, and maybe those products aren't compatible. So signs of mixing, severe wear conditions, and figuring out the wear mode that's present there, not just the amount of metal particulate, but also what kind of mode is it? Is it cutting wear? Is it signs of a lack of lubrication, oxides? This is all helpful. And then also looking for contamination, moisture getting into the grease, dirt getting into the grease. And this is a different part, a different thing for grease. If we have an oil sample bottle and we take that sample and we hold it up to the light, sometimes we can see some cloudiness, and it gives us the idea that there might be moisture in there. Or we let it sit on the desk for a while and we can see a little ring of debris settling at the bottom, that there's contamination, but you will never see those things with grease. Okay. Grease can accommodate a huge amount of moisture, tens of thousands of ppm, before it'll ever change its appearance in many cases. And you'll never have particles settling out. So contamination is hard to see unless we do grease analysis. We can also use a screening tool, and this turns out to be very effective when implementing a grease analysis program. Yeah, it's nice to analyze for all the possibilities that are there, all the different things I can see, but there's real value in, instead of just taking like one machine and analyzing everything we can, taking a number of different machines and doing a screening test and say, have there been changes? Are any of these an outlier? Especially when we have fleets that we're looking at, or situations where there's a lot of similar machines in similar operating environments. We can compare that data from a screening analysis. Just a couple of inexpensive, quick, sometimes tests that we're going to do right on the site without having to send off to a laboratory, that tell us, is this sample worth going into that next tier or that next level and upgrading to a full analysis. Routine grease analysis helps us maximize the life of lubricants. It supports sustainability, creates cost savings and labor savings across the board. And I'll talk about that as our series goes on here. We'll focus on some things like that. Return on investment from grease analysis, some case studies that point us towards sustainability of our assets by using grease analysis. And then routine grease analysis can establish trends based off of an equipment type, the operating conditions, hours of operation, these sorts of things. So how do we get this good sample? Well, I mentioned ASTM D7718. There's different grease thief kits that are out there, the different kinds that we have. Some of them are based on the application, things like the wind turbine kit, the robot kit, electric motors. We have ones that are optimized for pillow blocks and motor operated valves. All of these kits that are available are compliant with this ASTM standard that I talked about. So I'm going to knock down the full screen here a minute so that you can see me kind of here in the corner, and I'll do some demonstrations as I'm discussing it. But this is this kind of standard grease thief kit that we have that gives us a number of options. You can see here that we have the different on the end, the different kits. And this one here has a little marker here that indicates that this is loaded up for wind turbine sampling. And then with this as well, you can see there's a QR code here, and that QR code can be clicked, and then a series of videos is available to show you how to use the kit to get a representative sample. But it all takes you back into that process. I open the kit and I find instruction cards, which in addition to those videos, walk me step by step through the process of getting a representative sample per the ASTM standard. I pull out individual sleeves, one each for taking a sample. And these sleeves are, they're in a protective bag here that's sealed up, so you know that they're clean. Just like that consideration for oil analysis, where we're concerned about the cleanliness of the sample bottles we use, we have to worry about the cleanliness of the supplies that we use to take that grease sample and be sure that they're not contributing things that'll be measured in the analysis process. So it's sealed up. I can open that up, access the components inside, and use different tools that help me extract the grease from that component until I can finally get it into something that we call the grease thief. And this is the grease thief here. So what I'll do is I'll back out of our presentation here for a moment. I'll close that down, and I'll try to take the lead here. You might have to click on my image here to bring this up full screen so you can see what I'm doing a little bit better. But this is the grease thief. So the grease thief is a small plastic but precision designed device that allows us to take a representative sample of a target quantity of about 1 gram of grease. And for those who have, looked to perhaps internally or to other labs for grease analysis solutions, sometimes find themselves being asked to take very, very large samples of grease, 100 grams, 200 grams. Some of those quantities are required for grease analysis tests that are typically used on new greases to qualify their quality, their performance, how they are designated for sales, such as their NLGI grade and so forth. But they don't necessarily tell us much, if anything, about the in-service condition of the grease. So the grease thief is designed to be the tool that helps us take that sample, but also a quantity of grease that's reasonable to obtain, and then also gives us enough that we can analyze and see many different results. So with this 1 gram of grease, we can get up to 10 different tests in the laboratory. So what's in the grease thief? Well, we have a little cap on the end of it to keep it clean and keep the grease inside. We have a red piston in the middle there, and you can see when I hold the handle, I can slide that piston forward and back. And what that does is it creates a cavity that expands as grease enters. And so there's a couple ways to achieve that. One is I can take this thread and thread that right into a machine and let it sit there in place of a drain plug. And then as grease is purged from that location, it pushes that piston down, and the air that's in there comes out the back end, right? So this fills up with grease, and now I have captured here a sample that's representative, the most recent grease to be in that reservoir, in that housing, what have you. And then I can put the cap on it and use that for analysis. The analysis can be as simple as looking right through this clear plastic body and looking in this window and saying, how does that compare to the color, let's say, of the new grease? Is it green? Is it red? Is it blue? And what am I getting out of that machine? I then, another feature is that you can see here where the piston is. If the piston goes all the way down, it opens up a hole. That's a drain hole. That's a purge hole. So if I put this into a machine and the grease is being added and it pushes that piston down and it completely fills this housing and there's no more room to go. It's going to backseat the excess is coming out, and I'm still purging out the excess grease from that reservoir. But the most recent grease to be in the machine, the last to leave it, is what's captured here, and that's going to be my sample. Then these kits will give you the other tools you need. Like now that I have it in the grease thief, I want to be able to protect it. So we've got a protective tube here. I drop that inside. I close that up, and I put a label on that tube and send that to the laboratory for analysis. So these are the things that go into the kits that we talk about. Another option, if I'm not, kind of filling the grease thief manually, or also screwing it into the machine, let's say, we have a tool here, and you kind of saw a picture in my slide with the T-handle design, and this is the tool that we can use to extract a grease sample from the machine. So it has a knob here. I remove that, and then I have a little keyhole cut out here at the end, which fits right into the handle of the grease thief. That drops down, screws in place. And now what I can do is put that piston at the end. Now, when I put this into a machine, it's going to push grease out of the way until I get to that point that's right next to the component that I want to sample. And at that point, the body slides forward and I core the sample. It's not a syringe. It's not a suction device. Grease doesn't respond well to suction. If you try to put a suction on grease, you'll get liquid out or soft portion. What we want is to core that representative sample, and that's what comes through with some of these tools. So in other workshops that we have and so forth, we'll go into more detail about sampling, but I just wanted to show you how the grease thief is a little bit different and how these kits that we have available can be part of the solution for various challenges that we have in terms of obtaining a representative sample. And it really is equipment and application specific. So what I'll do here is I will roll back into our slide. I'll put that up full screen again and just kind of finish the thought here, which is two different types, the type 1 and the type 2 grease thief. The type 1 is what I've showed you here in the presentation, and that has this kind of open end, a piston in the middle, and a handle around the, all fit within this body. The type 2 has a stinger probe on the front of it, and that's for when we're not sure where that target is, how far into the machine we need to go. This will allow us to feel through the cavity, through the grease, until we end up adjacent to that component, that gear surface or that bearing surface, and then take that last several centimeters of grease that's going to be representative. So all of this that I've talked about is then compliant with ASTM D7718 and addresses the issues, the variables that are present in obtaining grease samples. If we can remove those variables and have a consistent way to get a representative sample, then our confidence in the data that we get from analysis will be much greater. There's another tool that I want to introduce briefly here this morning, and that's called the pickpocket, the grease thief pickpocket. Kind of a funny little name that my wife came up with, because we've taken this idea of the grease thief itself, or maybe like a straw, a big straw or a tube that we could sample, and turn it into a small solution. It's the same diameter opening to get inside of a machine, but it's a smaller diameter than the grease thief requires. So we're down to something around 8 millimeters in diameter is all the larger that opening needs to be. And we can get inside and we can core the sample in a very similar way. It automatically separates that smaller section and transfer that to a testing vial. And it's kind of a version of the grease thief that's low tech, if you will. It's lower cost sampling. We can do testing for color and ferrous content, and it's that first screening level analysis. And then we can transfer using that retained piston that's in the tube at the end there, and transfer the grease reliably into a grease thief for testing. Anyone who's tried to take grease samples without the benefits of these tools knows how difficult it is to jam grease into a small opening. to try to make grease fit into a small tube, let's say for some kind of testing. When you use the piston tube arrangement that the grease thief or the pickpocket has in this case, you eliminate that challenge. You have a reliable, easy way to take a representative sample that is compliant with that ASTM standard, and it's representative, and it gives us confidence and some low-cost options for grease analysis. So the next couple of slides I've showed you really kind of manually here, so I won't go too far into the details here, but you have these as a reference. We can use the T handle like I showed you, and then it's flush with the body, and then it cores that sample, and you can take that out. The one thing I want to add to this is that unlike oil sampling, grease sampling doesn't have the requirement of the machine must be running, or I have to get there within 5 or 15 minutes of shutdown. And those of us who do oil sampling know that's the reason, right? Because if we don't, Sonia, what happens to the particles? If I don't take...
Everything goes all over the place, and it's not representative. Just like you're taking a blood sample, if you have diabetes or something, they tell you don't eat on the morning, right? Yeah. Before you take the sample. So, basic simple things that we have to do in everyday life applies to your equipment as well.
Yeah,
so,
absolutely. And for oil analysis, when we have particles that, or even contaminants that are suspended while it's being agitated, while that system is running and while it's being circulated, when it stops, those things settle out. And if we don't get there soon enough, we'll miss them with our sample. It's a very valid approach for oil analysis. But for grease analysis, we don't have the same concern. Why is that? Because when the machine stops, the grease holds everything right there. So when we're targeting a grease sample, the location is critical. We have to be close to the area that is generating where contaminants that are present will be influencing negatively the grease in the operation of that, but we don't have to do it right away. It's an exception to that rule. We can come back hours later because everything gets held in that one location and nothing settles out in grease. That's one thing that's a little bit different. But getting to that representative zone in the machine is quite critical. Chipilla blocks, very common component. We're going to see that in petrochemical facilities and all sorts of operating environments. And so there's a kit for that. Depending on the size of it, there might be an external access. There might be a drain plug that we can get to or something like that. In other instances, we're just going to have to take that sample of purging grease. And we want to consider, hey, we don't want to get that contaminated. So there'll be some guidance on that. How do we go about it? What are the tools there that help us get a representative sample of the grease that is just purging out of that location? And then all of these things are then transferred into a grease thief or a similar sampling device for analysis. And you get this common target volume, about 1 gram of grease, and we can do all the tests that we need to do as a result. So first part of the meeting today, I wanted to focus on grease sampling, kind of drive home that point. Now I want to pivot into grease testing or grease analysis. And there's another ASTM standard for that. That's D7918. So the first one was D7718. Now we're on to 7918. It was a couple of years later, just happened to have a similar ending component to the number when they assigned the ASTM standard, but it does make it easier for us to remember. D7718, D7918. D7918 characterizes the wear levels, the consistency, the presence of contaminants, and then the oxidation condition of a grease sample. And you can see here that we can represent this in kind of a four-sided figure here that represents what are these different areas doing. Wear, consistency, contamination, and oxidation, we can color code them. We can give them green, yellow, red designations, and then kind of an overall rating for that sample as a whole. And by looking at these values, we can see signs of mixing, excessive wear from bearings and gears, contamination at unacceptable levels, or even depletion of antioxidants that tells us that this grease in its current replenishment practice is getting very close to the end of its life, or perhaps has already been depleted. That knowledge can really help us manage our assets. What are the tests that are found, the specific tests that are found in ASTM D7918? Well, there's a ferrous debris method. So we're looking at the ferrous debris, the iron-containing steel type particles that we get from bearings and grease and gears. And our method uses the FerroQ. There's a company called Poseidon Systems that's well known in the wind industry for their remote sensors. We've taken their technology and adapted it to a tool that can measure reliably and repeatably the ferrous concentration in a grease sample just by dropping the grease thief right into it. Quick test, repeatable test. In fact, the ASTM standard 79918 was just revised within the last few weeks following an international laboratory study to look at the results and to create a precision statement for this method. And the FerroQ was clearly a superior methodology. Some folks may be familiar with PQ. PQ is different. PQ measures differently. It can be very effective for oils, but grease is different because the samples that we submit are not homogeneous. We can't shake them up and make them uniformly distributed, make those first particles uniformly distributed. Therefore, the measurement is very different. And that's why we show, or why we've developed this FerroQ method for measuring reliably the total ferrous debris present. There's also the dye extrusion, and that's the picture you see right there. That is a picture of some very light colored or almost white grease being extruded through a die. That's the square piece that sits below the grease thief in that picture. And this device controls the temperature and then also the speed at which we extrude or press or push the grease out through a narrow flow channel in this die. And then it comes out as a thin ribbon. It's just about 1 millimeter thick. We can measure the consistency changes of the grease relative to the new grease by looking at the amount of force that's required to extrude that grease and how that changes over time. There's also particle counting. Folks don't all realize that we can now look for cleanliness in greases, and of course particle counting in oils is well understood, very critical, and there's just a lot of effort expended in filtration and other methods to keep oils as clean as we can. Well, a bearing doesn't know whether it's being attacked by particles that were in an oil or a grease. It just results in damage to that bearing. So we can now count particles and establish cleanliness targets for grease. And when I think about the Kingdom of Saudi Arabia, one of the things that comes to mind is how challenging it is to operate assets in a part of the world that has this prevalence of sand and dirt. And it's a constant challenge. And it's a great testament to the resourcefulness of asset managers in the kingdom that are able to get reliable operation in this very challenging environment. But it's difficult to ever see that particles, even a small amount of particles, are getting into greases to a point where they can be damaging. So this is a way that we can count particle cleanliness in greases, not only while it's in the machine, but think about storage practices, think about grease guns and other things. And so we can now bring particle counting to that aspect of things. If we want machines to last as long as they can, we want to keep the contaminant levels very, very low. And we do that by measuring those values to evaluate the effectiveness of our efforts. Color is another tool that we use. Most folks are familiar with colorimetry as a tool for varnish detection. Sonia has been very involved in some of the presentations and conferences that have been out there talking about varnish and varnish impact and measuring varnish levels using the membrane patch colorimetry, for example. Well, grease color is pretty important as well. It doesn't change the properties of the grease, but it tells us a lot about the grease. And so we've developed a grease thief colorimeter. It's similar to that micropatch colorimetry in that we present a thin film of grease for a spectrometer to measure the color, compare that to the color of the new grease and look for changes that might tell us about mixing or oxidation or other changes in the properties of the grease. There's also a humidity sensor. We're using a device called the Vapor Pro. And the Vapor Pro doesn't use chemicals like Carl Fisher, if you're familiar with that from oil analysis. Instead, it heats up that sample, transfers the moisture that's present in the grease off of that thin film that's created, and then measures that using a humidity sensor. So very effective way of measuring the moisture level in grease reliably. Crackle test doesn't work well for grease. Even Carl Fisher has its challenges. This works really well. And then finally, the linear sweep voltammetry, or the test we mostly know as the ruler test, lets us look at the antioxidants. And I truly believe that most of the grease in the world is wasted. I think we probably use about twice the amount of grease that's necessary for reliable operation of our machinery. We do it to be safe. We do it to purge out contaminants. And we think, well, it's better to use more grease than it is to damage the machine. The result is that a lot of good grease gets purged right out of the machines. We have people greasing much more often than is necessary. If we apply these principles of analysis, including looking at the antioxidants, we may find that there's substantial remaining life in grease when we're out there adding grease through an auto luber or with a manual grease gun. And if we optimize that, we would save a lot of effort, a lot of time, and certainly some money. So what is the right test slate for the application? And, as part of this Blitz, we say, well, where do you go with grease analysis when you want to do this? Well, you can start with the grease screening analysis that I talked about. And that'll typically be a test slate that's colorimetry, ferrous content, and maybe also FTIR. And it's great for large fleet management. Robots, wind turbines, locomotive bearings are some of the examples that we're doing this for. You can do a lot of this on site too. You can get a grease thief colorimeter and a ferroQ, and you don't even need solvents. You can test for the ferrous levels and changes in grease properties with the colorimeter just with a simple device you can put right on your desktop and test these samples right on site. If you get a handful of those that look to be different or significantly changed, then you can take those handful of samples and send them for analysis. So having some on-site capabilities is a good approach too. The basic grease analysis, we add to those first few tests, we add the dye extrusion that I showed you, moisture testing, parts per million moisture, as well as that full elemental analysis. And that really helps us understand what kind of metals are present or what kind of contaminants are there, including the additives in the grease and other things that work their way in from the process. So this could be for new sample locations. We build the trend data over time, and then samples that have known issues, then we need to monitor them at an increased frequency. And then finally, we can get into advanced grease analysis, and that is adding the tests of analytical ferrography and rheological analysis. This is for real high-value assets that are hard to replace or take a lot of time. When they go down, they have an impact on production. If we have samples that have known issues, we need to understand what's going on. This can really get us down to the level of how is that grease performing? Is it staying in place? Is it flowing? Is it separating? Is the oil separating from the base thickener? All these can be determined with rheological analysis. And then, of course, the wear modes can be figured out with analytical ferrography, just like they can for oils. We can do this now for greases. So I'm going to present to you that there are 7 key steps in establishing an effective grease analysis program. And depending on where you are presently, and if you're in Saudi Arabia, there's a good chance you don't really have a lot going on at this point. So you may start slow, try to learn some things, try to build some momentum, and then really demonstrate the value. But it always is going to start with what do I include? What do I start with? What kind of case can I make? What are my critical components? What problems can I solve? What long-standing problems? What headaches do we have? Or what are my most critical grease lubricated components? And so I select that appropriate equipment for inclusion. I prioritize the start of my effort. The second step is, and this one's tricky, I need to evaluate grease flow in the machine to determine the live zone target. If you've done oil analysis, you've done this. You've said, where do I get my oil sample from? You could go the easy way, which is, hey, there's a drain valve over there, and I'll just drain whatever comes out into a bottle. And those of us who have been doing this a long time know that that isn't always going to help us. That is an oil sample, but it might not be representative. And I might be chasing data that doesn't matter. So here now, I need to take it to another level. I need to ask that question: where does the grease go in this machine? What parts move? How do they move around? How quickly? And what areas, what geometric areas within the machine do I need to target to get the grease that'll tell me the story of what's happening now? That's the live zone. Now, the benefit with grease is I can wait till the machine shuts down, and then I can go and get that zone. But I always have to know where it is, and I have to get the right tools assembled to go get that. And that's some of the things that I showed you here today with some of the kits that we mentioned. And so there you are. Step 3, get the kits, get the appropriate equipment to get that representative sample. Step 4, establish an operating procedure for grease sampling methodology. Getting the kit is helpful, but then you have to have a procedure. Now, we do have the instruction cards that are in there, but you need to at least set the expectation that they are followed step by step and that they apply to that machine. So regardless of who's out there taking the sample, they take it the same way every time. The next step, step 5, create an appropriate and cost-effective test slate that is right-sized for that component. We gave you 3 different levels: the screening test, the basic, and the advanced. But get the right cost-effective test slate that helps you achieve your monitoring goals. And then next step, step 6, generate a sampling schedule with optimized frequencies. We know from reliability-centered maintenance that we focus on our most critical components. And our most critical components will get sampled more often than those that are not as critical. The optimized frequencies might come about over time. We might sample more frequently at first, but then relax later when we understand how quickly parameters are changing. That's that P to F curve discussion that we hear so often. We apply that to analysis frequency as well. And then finally, the last step is we want to review those analysis results for systemic issues. I send one sample off and I get a data point back. It tells me about that machine. But what I really want to understand is, how do we get to this point? What can I learn from this to apply it across my facility, across the fleet, in other locations with similar equipment? Because systemic issues that are proactively addressed will really improve reliability and life of our components and be a huge payback on the investment that we have to make for grease analysis. So here's a slide that I put together to try to prompt some discussion, and I hope we get a chance next here to do that, whether it's today or in follow-up. Some of that follow-up can be messages to Sonia or myself, or things that we'll tackle in other workshops that we'll have as time goes on. But there's a real chicken and egg dilemma here when it comes to Saudi Arabia, and that is there's not a lot of resources here. I sent out on LinkedIn, for those of you who are on LinkedIn, I set out a poll this week, and I said, which of the following countries does not have laboratory grease analysis capabilities with the Grease Thief? And I got some results there. And when I put this poll together, I listed 4 countries, and they were Poland, Canada. What was my other one? Poland, Canada, Saudi Arabia.
I remember there was one more, but I can't remember what it is. China, yes.
That's the other one.
Oh,
and
yeah.
then I asked folks, I said, out of these, with this poll, I said, out of these, which is the one that has a bit of a challenge here because it doesn't have any laboratories in country with the ability to do the grease analysis that we've talked about today. And my responses that I got from the poll were actually quite broad. Pretty much everybody picked those countries, and it was pretty spread out. But I think we know that today that the answer is Saudi Arabia, because China, Canada, and Poland all have these capabilities. They all have grease thief analyzers. They are stocking and distributing kits, and they have the ability to do it in country. You can add to that list Spain. You can add to that list several locations in the US. And so the capability is out there. And the chicken or egg dilemma that I talked about is what comes first. If the demand isn't there, if the asset owners aren't asking for grease analysis or know it can be done, then it's hard to see an entity invest in creating the capacity and the capabilities in country to do so. And so we want to ask that question: what approaches will help us solve that dilemma of what comes first, the demand for grease analysis or the capability for grease analysis? I've kind of put together some ideas for progress. We can as an initial strategy, export some compiled samples back to the US or some of these other places that I mentioned that have the capabilities to do that. But I know that's not a long-term solution for Saudi Arabia because of export limitations. That is not a viable strategy in the long term, because it's a country that wants to focus on using its own resources to solve its own problems. Another could be to create a consortium for demand. And I got to give a lot of credit to Hamza for starting us off on this. Not only did he come to us and say, this is something that my company, Sedera Chemical, could definitely benefit from, but here's other companies that I know could also do that. And so I see his efforts as the start of this consortium of demand that could ultimately be sufficient to attract the investment needed to create the capabilities in country to do this analysis. Ultimately, what we're looking for is to see a lab built in the kingdom, or to expand an existing oil analysis laboratory with the capabilities to do grease analysis. And that's a very practical way to look at this. Some of the tools that I showed in the analysis piece, they go hand in hand with what you find in an oil analysis laboratory. So can we find an oil analysis lab partner that sees the benefits here, sees the interest and the value in expanding and adding these capabilities in country? I mentioned SGS as well. Working with Hamza, we have worked with SGS to receive some of the samples and to get them analyzed. SGS does have this capability, just not in Saudi Arabia right now. And certainly the business decisions are going to be driven by demand. And so if there's enough interest in demand, then you could possibly see that investment. So I bring that up as something for us to think about. And all this is to try to drive this vision of having laboratory capabilities to support this interest. I'm open to partner suggestions for stocking and providing the sampling kits that you see here. Presently, we're just shipping them to individuals. We shipped kits out to Hamza for some sampling he did there. But if there is a good partner in the kingdom that we can partner with to get these kits stocked and available for those who might consider grease sampling, then it's good for us to hear that. And one of the things that I'm committing to is we support expanding the knowledge and value of analysis in Saudi Arabia, and our partner Sonia here does obviously as well, and she's given generously of her capabilities and her time to bring this to you today and as we go forward. So that's where I want to leave it, and I'll close this screen at this point, and Sonia, let you take the discussion from here.
All right, because we have one major question coming in from Joshua, and he's asking, what are some of the major savings associated with a grease program? Oh boy, I'm going to leave that one to you, but there are a lot of savings.
Yeah, I have a few, and one of the things we can do, Sonia, is I can share some white papers, some presentations I've done at other conferences, and there's one that really answers this question, I think, very effectively. And I have 3 examples. I tried to think of something in the petrochemical area that I think would hit home for a lot of our participants here. And I don't really have a shareable example in that space, but I do have them for helicopters, military helicopters. I have them for robotics, and I have them also for locomotives. And so the three quick hitters on this is on the robotics side, working with a major international automotive manufacturer. They did a series of grease analysis tests so they could go from a time-based to a condition-based changing of the grease in the robots. These are the 6-axis robots that are assembling things, anything from a Tesla to a Honda. Those joints are going to be filled with grease, and historically it's been every so many months of operation, regardless of what the robot is doing, you change all the grease out, shut down the line, very time consuming, very costly. So one particular auto manufacturer with their fleet of robots was saving $80,000 net, $80,000 per month, or I'm sorry, per year on 300 robots by reducing grease consumption. Some of the robots had to be greased more often. Most of the robots could be greased less often, but the work there was optimization. Another example, locomotive wheel bearings. Worked with a major freight moving railroad to do grease analysis. And this is just with the screening tests that I talked about. They were able to use this as a tool to find problems in the bearings for the wheels. They were able to cut in half the number of failures that were happening with a loaded train. So when you have to take all that freight and get some other vehicle out there to move it, very expensive. By cutting that in half, they're saving $500,000 per month by not having to defer those shipments. The last example I have, and I have a publication on this that was done in a military helicopter conference, and that was using the grease analysis for the Chinook fleet. And I believe there are Chinooks in Saudi Arabia as part of the military efforts there. But this is a heavy lift helicopter. We were able to look, and again, this is a helicopter that's been in service for over 60 years, back to the 1960s when it was deployed. And so over time, it was like, we'll just keep greasing it. We'll keep it safe. We'll keep it greasing. Determined that the greasing was way more than it was necessary. The result was to more than double the flight intervals when it needs to be greased, from 50 flight hours to 120. Cut the number of greasing tasks in half for every 1,000 flight hours, saving approximately $100 million per year across that fleet of a couple thousand helicopters. So I think the idea here is that the applications are out there, the cost benefits are out there. They may not be what's published exactly what your situation is, but it all comes down to the fundamentals of, do I extend the life of the equipment? Do I get more life out of the grease and less labor required to grease components? And do I ultimately have a more sustainable physical asset operation by applying grease analysis?
And I think safety as well, because there are certain points that are very difficult to reach for some people.
Yeah, there is. That's a great way when you brought up. There is an example that I have from the power industry, and this is a component that is prevalent in petrochemical settings, and that is motor-operated valves. So you have these remotely operated motor-operated valves that often have grease-lubricated gearboxes between the motor and the valve itself. We did some testing for a power plant in the U.S., and they were able to indicate that by being able to relubricate in a more targeted way and less often, the complete disassembly, the rigging of the parts actually made for a substantial increase in the safety for that operation. So it's there as well.
Oh, yeah. And we have a question coming from Mohammed, and he's asking, can we test the grease sample for all of the tests under the advanced package, just using 1 gram of the sample?
Yeah, people hear that and they're like, wait a minute, you're going to come back and ask me for more grease, aren't you? And it's hard to believe, but we showed that little picture, and we're going to dive into this more, Sanya, in the other workshops that we have. And you'll actually see that when you get that grease sample, just a gram of grease, and you take it down to 1 millimeter film, it's like, like 14, 15 centimeters long. And you can take those individual sections, and each of those can be analyzed in a different part in the lab. So the answer is yes, we can analyze that full test slate using that 1 gram of grease. The only thing we can't do is compatibility studies. If you have a question, does this grease compatible with this grease? We're going to need a larger volume to simulate that in a bearing housing and so forth. But all of that test slate up through the advanced testing can be done with 1 gram of grease.
That's so good to hear, because I know the amount of grease that is available for us for testing is very limited. So, Mohammed, I had one more question though.
Yeah, sure.
Can we test ferrous iron using the ferro cube?
Say that again?
Can we test non-magnetic actually?
Yeah, okay.
Using the ferro cube?
Primarily, no. It is an induction coil method. So there are some what we might call paramagnetic materials that do influence that somewhat, but for the most part, it's ferrous. So what I would say about that is the reason it still tends to work is that most applications are either ferrous or combined materials, where those other materials aren't preferentially wearing. So if you'd have maybe some kind of grease lubricated bronze bushing, then you might have to go to another level for that, because it's possible that the bronze could wear, but the majority of grease lubricated components are ferrous in nature, and so it does become a valuable tool. But no, you can't see for that particular test beyond the ferromagnetic or paramagnetic particles.
Okay. And Hamza is asking a very interesting question as well. More people are going for ultrasound regreasing these days, and I've seen that a lot, thinking that you could identify the problems at an earlier stage. What is the trade-off between grease analysis being a better option compared to ultrasound regreasing? How does that work together?
It's a great question. I think they're complementary in a way. I wouldn't say it's an either-or proposition. The primary thing that the ultrasonic greasing does help you with is the concern about non-optimal relubrication for manual greasing. That means we take the grease gun out and we're adding grease, and when do we stop? When do we know how to stop? We can calculate things. It isn't always right. There's a lot of over lubrication out there, and I think this is really helping to reel that back in. Like, I'm a farmer as well as a scientist, which kind of blows people's mind a little bit. But I've learned as a young person, just you go out and you grease until it squirts out somewhere. And if you apply that in most of our industrial machinery, you're going to get yourself into big trouble. So ultrasound is a great tool to reel that back in. But what it doesn't tell you is what is the condition of the grease after that interval. Has the grease between the 2 visits you made with your ultrasound, has it actually degraded in that time and resulted in damage to the component? Okay, so they are really complementary in that way, and we learn different things about grease aging by looking at those 2 tools. But the best situation is to use them together.
I agree with that, because there are certain things that, both of them have their benefits. So it's definitely not an either or. And we have Kevin asking, what is the optimum frequency for grease sampling?
Sure. I mean, unlike oil, sometimes the available frequency has to do with how often we're regreasing things, because often we depend on the new grease going in to push the old grease out. So, we're sometimes at the mercy of when the grease is available, or like in wind turbines, how often does someone climb up there to get a sample? I would say there's a lot of really critical components in oil settings where you might be out there once a month, or there's even situations where we're continuously monitoring with sensors now on the oil side. I would say quarterly is the most common, critical frequency for most sampling tasks, and sometimes two or three times a year is optimal. But I think ultimately we learn that over time, and we make adjustments to that. So it's dependent on the application. But what I would say about that in terms of that optimal frequency is that one difference between oil and grease is that grease is cumulative when it comes to wear. Okay. When I take an oil sample, as long as it's in that kind of equilibrium condition and all those stuff is settled out, the filters are taking stuff out, and I get that snapshot, I can look at that over time. But if you look at grease after 1 week, 1 month, 2 months, 3 months, it's going to have an increasing amount of wear up until the point that you completely replenish it with new grease. So we always want to carefully keep track of how long has that grease been in service since it's been replenished, and consider that when we look at the overall levels of wear in the samples that we take.
That's a really good point, because I think that's where trending is very important.
Yep.
Taking those samples, consistently and making sure that you have that data, because if you just take a random sample, it can be any amount.
Yeah, and you could have a different amount and the same wear condition.
Yes.
So knowing that interval is even more important for greases than it is for oils.
It is, definitely. We had so many good questions today. I know we are a little bit over time, and it is 8:05 p.m. on that side of the world. So I don't want to keep anybody back too much from their dinner or their bedtimes.
But Sonia, you'll be reaching out with folks on scheduling the next event. We have some more events coming up, and we can get to more questions then for sure.
And make sure I dropped a link in the chat for the Google form to sign up. Sign up with the Google form so you get all of the alerts, you get all of the webinar dates, because I know you have to block your calendars early. Make sure you have that. We will be posting on LinkedIn, our next set of times. So just look out for that. I know you all are very active on LinkedIn. So I see you all in the group and stuff. So make sure and be aware of that. We are doing a lot more of this because our aim is really to increase the awareness, make sure that a lot of people are more aware of what they can do with grease analysis, especially in KSA and the surrounding areas. So I am so grateful that you all took time at the end of your day, at a very long day, to still sit here with us and have a great discussion. So
Sonia, thank you to you, and thank you to Hamza for having the idea behind this, and of course everyone that's participated. This will help us create this community, and it has to be a community that we can kind of get our ideas together and create that opportunity in the kingdom that's needed to bring grease analysis as a tool that exists in Saudi Arabia.
Definitely. So look out for the updates, and we will be seeing you all and talking to you all soon. All right.
Thank you so much.